Simplify. 1111 over 101 all in base 2, right? 1111 all base 2, yeah. So let me see if I can share this board into 3. At least it will be better. If I can simplify. Now, this is it. I have to simplify this. Just to divide this by this all in base 2. And then from what I told you, we have to convert each of them to base 10. After converting to base 10, we now divide in base 10 and then convert it back to base 2. Now the first one there is 1111 and it is in base 2. Converting it to base 10, we do the normal multiplication. This is raised to the power 0, raised to the power 1, raised to the power 2, raised to the power 3. So we have 1 times 2 raised to the power 3 plus 1 times 2 raised to the power 2 plus 1 times 2 raised to the power 1 plus 1 times 2 raised to the power 0. This is 2 times 2, 4, 4 times 2, 8, 8 times 1 is still 8, 8 plus 2 times 2, 4, 4 times 1 is still 4, plus 2 raised to the power 1, 2, 2 times 1, 2, plus 1, 1 times 1, 1. And then when you add these 8 plus 4, 12, 13, 14, 15. And this is equal to 15 in base 10, right? And this is just the numerator. Now let's look at the denominator. The numerator says 101 in base 2. And then which is the same thing as raised to the power 0, 1, 2. This is the same thing as 1 times 2 raised to the power 2 plus 0 times 2 raised to the power 1 plus 1 times 2 raised to the power 0. This is equal to 2 times 2, 4. 4 times 1 is still 4. Plus, this one is gone. Then this times 0 is gone. This is raised to the power 1. To the power 0. 1. This is 1 times 1 is 1. And this is equal to 5 in base 10. And then, 111, okay. This is the numerator. And which is equal to 15 over 5. All in base 10, and that is equal to 15 in 5 is equal to 3 in base 10. Now we've converted to base 10 and find the solution, which is 3 in base 10. Now we have to convert this 3 back to base 2, and to do that, 3 base 10 to base 2 to base 2 to do our normal division. 3, 2. 2 and 3 is 1 remainder 1. 1 remainder 1. Then 2 and 1 is 0 remainder 1. And then when you take it off, so which is equal to 1 1 in base 2. Therefore, this 1 1 1 1 all over 101 all in base 2 equal to 1 1 in base 2. It's just, let's say, the minor of division of number bases. Another example, I don't even know which example it is, all I know is example. Another example says simplify. Simplify 1,222 all over 10,201. 1,222 all over 10,201. All of them is in base 3. Now see this one, this is not dot 2. In base 3. Now we have to use our normal procedure of converting each of them to base 10. And then divide and then coming back to base 3. And the first one there is 1 2 2 2 in base 3. And this is equal to converting to base 10. We do the normal multiplication. Raised to the power 0, raised to the power 1, raised to the power 2, raised to the power 3. And this is 1 multiplied by 2, sorry, by 3 raised to power 3 plus 2 multiplied by 3 raised to power 2 plus 2 multiplied by 3 raised to power 1 plus 2 multiplied by 3 raised to power 0, right? And this is equal to 3 times 3, 9. 9 times 3, 27. 27 plus 3 times 2. 3 times 3, 9. 9 times 2, 18. 18 plus 3 times 2, 6. Plus 2 times 1, 2. Right? 27, 9, 18, 6, 2. Now, if you add, we have 8, 16, 23. We have 3, 4, 5. I have 53 in base 10. 53 in base 10. Now, that is for the numerator. Now, let's go for the denominator. The denominator says 1, 0, 2, 0, 1 in base 3 is equal to, we're converting to base 10. 0, 1, 2, 3, 4. This is 1 times 3 raised to the power 4 plus 0 times 3 raised to the power 3 plus 2 times 3 raised to the power 2 plus 0 times 3 raised to the power 1 plus 1 times 3 raised to the power 0. First one, 3 times 3. 3 raised to the power 4, 3 times 3, 9, 9 times 3, 27. 27 times 3 is 81. So equal to, and 81 times 1 is 81. And then of course this one is 0 already. Whatever you get here, when you multiply it with this 0, it becomes 0. So that one is out. And this one, 3 times 3, 9. 3 times 3 is 9. 9 times 2 is 18. Plus 18. Then this one is gone already. And the last one is 1. 3 raised to the power 0 is 1. 1 times 1. So when you add this thing will give you what? 9, 0, 10, 10, 100. Am I right? 1 plus this is 9, 10. Right? 5, 0. Add 1 here. 2 plus 100. So this is 100 in base 10, right? So expressing it in this way, we have 53 over 100. And this will give you 0.53 in base 10. And now, of course, it is in base 10. We have to return it to base what? What is that? Base 3. This is where the work comes in. Is it that same math we are solving here? No. Okay, this is it. Now here, converting this thing now to base 3. Now, there are two ways to converting from base 10 to other bases. The first one is you divide that base 10 with the base you are converting to, and at the end you take the values of the remainder from the last to the first, or you multiply the number with the base you are converting to, and then the remainders, like this one, especially when it is in this decimal point, the remainders you take it from this side is considered the remainder. Then you take it from up to bottom. Let me show you what I mean. Like for instance, for this one, I'm converting 0.53 base 10 to base 3. Of course, the normal one we were taught, both in primary and secondary school, is you're converting anything from base, which is the one we did before. And if you're converting, assuming it is 53 from base 10 to 3. So the only thing is you divide. After division, you take the values from bottom to up this way. We are not taught the method of multiplication. But look at what I'm saying here now. To convert this thing now to base 3, you do 0.53 multiply by the base you are converting to 3. Now remember it's in base 3. You don't forget that. In base 3. Now 3 times 3 is what? 9. You write that 9. This one we are just converting from base 10 to base 3, but it has decimal point, so this is the way we do it. 3 times 3. So now we write the 9. Then 3 times 5 is 15. You write 15, write 5. Then that one that enters this side, take it as a remainder, which is 1. You circle it. Because it's a remainder, you circle it. Now that one is 1. Then you come and multiply this one also with 3. 3. Now 3 times 9. 3 times 9 is what? And now when you're multiplying it here, you're just multiplying it under base 10. It's not even, you are using base 3 to multiply it, but you're multiplying it. We don't do the one we used to do once you multiply, because the base is less, you divide with the base. No, this one is multiply it normal base 10 multiplication, but using base 3. Now this one now, 3 times 9 is what? 27, am I right? It's 27. Yeah, 27. Then we write 7. Then we hold 2. Then 3 times 5, 15. 15 plus 2 is 17. We write 7. That's one that crosses this side. Put it as a remainder. Mark it. Now we still multiply with 3 again. Now 3 times 7 is 21. Right, 21. We write 1, hold 2. 3 times 7 again is 21. 21 plus 2, 23. We write 3 dot 2. That's the remainder. Now, someone will ask, when should I stop? Of course, the first one is, you can choose to stop in 3 decimal places. That one is first. Or, once the number here is less than this number, just stop. If you look at this one, this is 3-1 or this is 5-3. So once you get to the point, you stop. So what it means now is that 0.53 base 10 is the same thing as, take this one, this reminders, same thing as 0.112 base. There. Did you see how this one is done? This is not the normal one we know we divide. Because this one has a decimal point. That's why we do it this way. We do it this way, sorry. So this is equal to this in base 3. But there's still another way. That one is another way you can do it direct. I mean direct from here. Just direct from here. And you still get this point. But let's just try it so that I will show you. But it's kind of